Okay, so we're going to look at our last section within the demographics page of the coding guides. And what we're going to focus on here is maintenance and generalization. So when I'm thinking about maintenance, I'm thinking about are the effects lasting long after the intervention has finished? Really, the only way to assess this in a group design study is if there is a delayed post-test. And the easiest way to see if there's a delayed post-test is if you go to the results tables. You can see here, table 4 includes a pre-test, a post-test, and then if there was a delayed post-test, it would be over here to the side. And there would be data for this delayed post-test, which normally happens a couple weeks or a couple months after the intervention has finished, to assess whether or not, those things the students learned, whether or not it's really stuck, and if they're still using them, or if they've still mastered that content. So for this one, you can see it's pretty straightforward. Without any delayed post-test data, there is no maintenance data being measured. Now let's say there was delayed post-test data. There's a couple options you can enter here. If the if the delayed post-test scores are the same, and there's no statistical difference between the post-test and the delayed post-test, then you can say that the the effects have been the same, they've been maintained throughout. If super awesome and the students' scores have actually significantly increased, then that's amazing. Then you can put a 2. Or, unfortunately, what typically happens when there's delayed post-test data is there is a drop. And if that drop is statistically significant, which it will usually signify in the paper, then you would put a number 3. And I want to show you real fast what this would look like for single case designs, because in single case designs, they do a much better job of always collecting that maintenance data. It's usually the third portion of the graph over here on the far right, and you can see it's measured here with the little circles as maintenance data, versus the closed circles or the filled in circles are the intervention itself. So I want to see, are the students doing as well, better, or worse during their maintenance compared to their intervention phase? So you can see Nick is doing just as well. Good for him. Jess, when we go back and they talk about tau u down here, that's another way to solve for the maintenance phase. So you can see her maintenance was a 1.0, which is like 100% for the maintenance phase. And then CC, you can see her tau u is 0.8, so it's less than 1. Or we can see here in the graph, her maintenance phase is lower than her intervention phase. Versus Jess, you can see all of her maintenance data is sort of captured within, or it's on par with how she did with the intervention itself. So we have the same, worse. So what you would do for that is you would type in a 1, 3. So it captures some students did as well, and then some students didn't do as well. So you would collect that across the students for single case design. So back to Dr. Bryant's, we didn't have any maintenance data reported, and now we're going to look at generalization. Now, generalization in group designs, what we have to do for this is we have to think about, is the intervention impacting more than just the specific skills that the interventionist is targeting? The way we do that is we're going to go back up to look at what measures they used. Boop, 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 all the way back up. Back up to the measures. And Dr. Bryant does a really wonderful job of being so descriptive of her measures. And what we're really going to look for are these keywords. So if something is a proximal measure, that means that it is measuring what the intervention is teaching. If the intervention is on how to multiply, the proximal measure will be math multiplication facts. So are you learning what we're teaching. The other type of measure that a lot of researchers will use are called distal measures. And distal measures are going to be that piece of generalization. So these are going to be much larger tests that will assess things you can see like math problem solving, computation, sort of a broader scope of are your general skills being impacted to the degree that you're just sort of better in math at these general skills. So the TEMI-O is a distal measure, and the Stanford is a distal measure. So what that tells me is I need to compare how well the students did on the first measure, which is the TEMI-PM, which was our proximal measure, and compare the TEMI-PM to how well they did on the TEMI-O and the Stanford. So I'm going to go back down to the results. Scroll, scroll, scroll. Scroll, scroll. A little more scrolling. Okay, so now I want to see, did the students do as well on the compare how they did on the TEMI-PM and see did they do as well on the TEMI-O and the Stanford. So, it's hard to gauge from the results table itself, so I'm going to go into their results paragraph. And what I find out is that the students scored significantly higher on the TEMI-PM. There was a statistically significant difference. The effect size was 0.66, so they did better on the TEMI-PM. They improved, the treatment was significantly better than the control group. Yes, that's exactly what we want to hear. So they did awesome. Now if I go down here to the TEMI-O, what it says is that it was not statistically significant for the TEMI-O, and then also, I believe they also and for the Stanford or the SAT-10. So what that means is students in the treatment group were not statistically significantly higher than the control group, which to me says they did not do as well on the TEMI-O and the SAT compared to the TEMI-PM. The TEMI-PM, they rocked it. There was a statistical difference. Awesome! Versus the TEMI-O and the SAT, it was not statistically significant. The other thing I could look at to sort of highlight that is I can compare the effect sizes. So the effect sizes show like how big of an impact the intervention had, and you can see in the TEMI-PM the effect size was 0.66 versus in the TEMI-O it was 0.14 and 0.13. So the students did not generalize. They did not do as well on the generalization test as they did on the original proximal measures. So they didn't do as well on the distal measures as they did on the proximal measures. So we can see here our options are they cannot be generalized, can be generalized, and then improved. So for this one we're going to put a 1 because they did not generalize. They did not do as well on the distal measures. And so I'm going to put here, my pages are 113 to 114. And then just real fast for the single case design, you can also do the same thing looking at the generalization. If they include it in the graphs itself. Usually they do. Sometimes generalization will be over here with the maintenance phase, but they usually always label it as generalization. So you can see for these students, once Nick actually receives the intervention, he does as well with the generalization. Jess does as well with the generalization, and then CC does not do as well with the generalization. So same thing for generalization. I would say, in this example, I would put a 2 because Nick and Jess are generalizing the information, and then I would also include a 1 because CC is not generalizing. So thank you for sticking with me for this video on maintenance and generalization. Tune in for the next video where we're going to start talking about the coding for effect sizes, which is going to be so much fun.